So now that we want to look at multiple products, what difference does it make? That's what we want to look at. Well, first thing I'm going to tell you is that it's not anywhere different from what we've been doing for the single product. It's just the approach that was slightly different. A slightly different approach, which you won't find any complicated. So, which means we're still going to be asking ourselves these two questions. But the difference is that instead of talking about units, we'll be using mix most times. Then we'll learn how to convert that mix to units. Because if you are producing more than one product, then that means you have a mix of products. Because if you are, take for instance, you have a company that is selling 3 products, A, B, C. Anytime they are selling, the assumption is that they are selling the 3 products in a mix. The question is, what is the mix? So for us to be able to progress and answer these 2 questions for a company that is producing multiple products, we must make some assumptions. And the key assumptions that we always make is that the products, these 3 products or multiple products that the company is producing will always be sold in a constant mix. The constant mix assumption is the most important thing here. So when we're talking of mix, we are just talking about ratios. That's what we're saying. In what ratio will those products be sold? That's what we're calling mix. So take, for instance, is it ratio 1 to 2, ratio 1, or ratio 2 to 3 to 4, whatever it is, you will be given. This is what you need for this particular scenario. Yeah, let me start from an easy one. Let's say 2 products. And you say the mix is that they're always sold in ratio 4 to 1. So which means if this company is selling 10 units of A, how many units of B do you think this company will be selling? Let me quickly test some mathematical concepts.
Was it 2.5?
Thank you. It's actually 2.5. Because if you are selling for ratio 1, so if you're selling 10 of A, then you'll be selling 10 times 1 over 4 of B. Because you are saying if you sell for A, you will sell only 1 unit of B. So if you now decide to sell 10 units of A, then you'll be selling, you need to cross multiply, 10 multiplied by 1, then divided by 4. And that is 2.5 units. Because you need to be able to do this kind of simple arithmetic in this scenario that we're assuming. So I'm not convinced yet. I'm still going to give you more. Ratio 2 to 3 is the mix for A and B. So if you sell 15 units of B, how many units of A did you sell? So look at it. You said A, B. A is 2 and B is 3. Now we are saying B is 15. What is here? That's what we're asking you. Because if you say A is 2 and B is 3, then when B is 15, then I always do this. Anyone that when you cross it, it complete. That is what is going to be on top. So 2 times 15, then you divide by 3. And that's 30 over 3. And that's how they got 10.
I got 49.
Fantastic. I believe everybody got 49, right? Yeah. Yeah. So now looks like that is good. Right. That is one thing that has to be clear to you guys. So that is called mix. That's what you call mix. It's just the ratio at which those products are being sold. Yeah. Sometimes you can have 2 products, sometimes you can have 3 products. Now let's test this again as well. So if my revenue total, let's say is 150, yeah, and I'm selling A and B in mix of 2:3. What is the revenue for A and what's the revenue for B?
Sorry, that's 60 for A and 90 for B.
60, 90. Okay.
Same.
Good. That's awesome. So the best way to do is just do the total amount divided by the total ratio, and that's 2 plus 3 over 5. So that means 1 ratio is 30. So now if it's 2 and 3, then 2 times 30, that's 60, and 3 times 30, that's 90. Fantastic. Okay, that's good. One more. Now we have 3 products, A, B, C. Ratio 2 to 3 to 1. Right? And we sold 5 mixes. What is total units for each product? Remember, this is one mix. So one mix means we are selling 2 units of A, 3 units of B, and 1 unit of C. But now we have sold 5 mixes. So how do we get the units that we sold for each product? How many units of A did we sell?
10.
10.
15.
15. And C, how many did we sell?
5.
5. Any question from anyone? All good? Fantastic. So that is the very basic operations that we'll be doing. So remember what I said. The assumption is that the mix would always be constant. That is the assumption. Yeah. So which means everything we did yesterday for a single product, we're still going to be doing it today. But instead of talking about units, we'll be using mixes. So which means the first thing we calculated yesterday was contribution per unit, if you remember, because we said contribution per unit during break-even will be equals to fixed cost per unit. But ladies and gentlemen, today we are not going to be using that ratio. We'll be using contribution per mix, and we expect it to be the same thing as the fixed cost per mix. Yeah. So remember, if you don't make this assumption, it will just be difficult for you to be able to do this scenario, because when companies are selling different types of product, there are different ways they can sell it. Some companies will prefer to focus on their profitable product first before selling the less profitable product. Some companies will decide to sell some product, maybe they are already going to expiry. So there will be a lot of different assumptions that will be going on. So it's almost impossible to be able to do this cost volume profit analysis without making this assumption. So that assumption just helps you to simplify your scenarios and your calculations without necessarily going to so many infinitesimal scenarios that you can face in reality, right? So that's why we are making that assumption. Now we go straight into the calculation, which is how many. So if the question can still ask you how many units, yeah, which is what we're still going to be doing. However, because there are many products, we'll be using mix to work the question. So, and I'm still going to ask, how many units do we have to produce? Yeah, to break even. That's what we want to do. And let's play with this question, A and B. With selling price of 3 and 5, let's say variable cost is 1.75, 2.3. Fixed cost is 27,000. And you have the mix, the sale mix. They are always sold in ratio 4:1. The question is, how many units do we need to sell to break even? Right. So this is a typical multi-product question where you cannot use contribution per unit to solve it. Although we are interested in knowing the number of units to break even, but we cannot use contribution per unit to solve this question. We need to know what our contribution per mix is. That's what we need to do. So, and how do you go about that? The first thing you need to identify the mix. Where is the mix? This is the mix, 4:1. So, which means for every mix, we must have sold 4 units of A, and we must have sold 1 unit of B. So, which means we need to know the contribution from 1 unit of A, multiply it by 4, get the contribution for B, multiply it by 1. Add it together, then we have the total contribution for 1 mix. So, which means the next thing we need to do is we need to get our contribution per unit still. We need it. And for A, that will be what? 3 minus 1.75, that's 1.25. And for B, 5 minus 2.3 will be 2.7. So that's contribution per unit. But for a mix, we need 4 units of A. So that means 4 times 1.25 plus 1 unit of B, that's 2.7 times 1. And what would that give us? Total contribution. 4 times 1.25, that's 5. And 2.7 times 1 is 2.7, that's $7.7. So this is contribution for 1 mix. Any question? Does it make sense? Good. So we know the contribution per mix now, yeah, which is the same approach that we used the last time, is to say at break even. One thing we know for sure is that the contribution must always be equal to the fixed cost. So which means the contribution per mix will be the same thing as the fixed cost per mix. In that case, it means that our fixed cost for 1 mix is equals to 7.7. So we expect the fixed cost for 1 mix to be 7.7. Then the question is, the fixed cost is now 27,000. How many mixes do we need to have 27,000?
I have 3,506.49.
So I can say 3,507. Okay.
Yeah.
That is the number of mixes that we need. So we need 3,507 mixes to break even, because that is when the total contribution will be equals to total fixed cost of 27,000. But that was not the question we are asked. The question that we're asked is how many units. But we know that we cannot calculate the unit without getting the number of mixes. So one thing that we know for sure is that the sale mix is always 4:1. So if the sale mix is always 4:1 for A and B, this is the mix. Yeah. Now we have 3,507 mixes. If we know that, how many units of A do we need? Are we going to get if we are selling 3,507 mixes? Or let me
14.
start with B. Kesha, how many units of B are we going to sell? One mix is 4 units of A, 1 unit of B. Now we are selling 3,507 mixes. What does that translate to for B in terms of units?
3,507.
Exactly. So 3,500 units of B. And how many units of A?
14,028.
So 3,507 times 4 and 1 times 3,507. So what do you get? 14,028, you said?
028.
Okay. Yeah. That is the number of units to break even. So you could see the way this is a bit different from what we did yesterday. Yesterday, we'll go straight to contribution per unit. We equivalent it to fixed cost per unit. We divide the fixed cost by that ratio and we get the break-even units. But for a situation whereby there is a mix, it is not as straightforward. We need to work the mix out first, then from the mix, we'll go back to the units. And I'm happy it's moving well because yeah, we had a warm-up for the mathematical part, so probably making it very easy. So that's for units. Remember, after units, we also did for revenue yesterday for units. Now we're going to be doing the revenue for mix. So the question is, we are looking at multiple products and we're asking ourselves, how much revenue do we need to break even? That's the question. Yeah. So the assumption is still going to be valid, which is, yeah, constant mix is still what we're going to be using. But remember, yesterday we did not use contribution per unit for revenue analysis. What did we use? What issue did we use yesterday?
Contribution to sales ratio.
Exactly. Contributions to revenue was what we used. So the same thing we're going to be using today. Yesterday it was about contribution from 1 unit sales that we are making, which is the selling price. Yeah, that is what we used. But now we're not going to be using contribution per sale mix. So like revenue, what's the best way that will probably stick better with you? Should I call it contribution per total revenue from a mix? Because I need you to understand first. Yeah. You can call it any name if you don't know what it means. So it's revenue from one mix. That's what we're looking at. So any way it works for you, you can call it contribution per sale mix. But just know that what we are talking about is the total revenue from one mix. Yeah. So if we stick to the same question that we are using to explain it, what is the revenue from one mix? Looking at this question. Remember, the selling price for A and B is what? 3 and 5. It's here. 3 and 5. And you know that the mix is 4:1. So which means one mix means you are selling 4 units of A. So if you're selling 4 units of A at $3 per one, it means you're making 3 times 4 on A. And you're selling 1 unit of B, that means that you're selling 5 times 1. And that is 12 plus 5. So which means anytime you sell a mix, you're going to make a revenue of $17. And if that is your revenue from one mix, you need a ratio that is called contribution per sale mix. And you already get your contribution from a mix. Your contribution from a mix is 7.7 here. So which means contribution per sale mix is equals to 7.7 divided by 17. And what is that? That's 0.453. So which means we know our contribution per sale mix. And once we know that, we can use the same analysis that we've been doing. Sometimes, please take note of this, because in case the question is maybe in your MCQ, they might ask you to calculate contribution per sale mix, or they can ask you to calculate weighted average contribution sale ratio. It's the same thing they are telling you. Please take note. Weighted average, I need to tell you this. Weighted average contribution per sale ratio. This is the same thing as this. This is just a complicated name. It's as simple as what you have calculated here. Please take note. Right. So now let's calculate our break-even revenue. We know our contribution per sale mix, which means that 0.453, yeah, is the same thing as our fixed cost per sale mix. So what we are saying invariably is that we make 0.453 fixed cost when we have one sale mix. So one sale mix is equivalent to that 0.453. And now we want to know how many sale mixes will give us 27,000. And we use the same cross multiplication times 1 divided by 0.453. And that will give us $59,603. Make sense? So that is the revenue, the total revenue that will make us break even. But the question might go further, could have asked that for each product A and B, what does that translate to? So we should be able to do the analysis. Yeah, and I'm happy we've tested it here. Let me remind you. And you got the answer perfectly correct. Kasia, you were the one that even explained it. Where is that? This one. Breaking the total into ratios. Now, it's the same approach you're going to do here. This is the total revenue of A and B that will break even. But remember that 4:1 is in what? 4:1 is unit mix. And we are dealing here with what? Revenue. So what we need to be using to allocate the revenue will be what? This 4:1, what does it translate to in a as a revenue mix? Which means that if a unit mix is 4:1 and A is sold for $3 and B is sold for $5, it means that the revenue mix is actually 3 times 4, which is 12, ratio 5 times 1. So that is our revenue mix. This is our unit mix. So when we are doing unit analysis, yes, we use this to split. But when we are doing revenue analysis, we use revenue mix to split. So this revenue of 59,603, we have to split it based on this revenue mix. And this is where a lot of practice will be quite important because you're going to make mistake. You can see even when I'm teaching it, I can mix it up. So now think about you that you're just hearing it for the first time. So you need to practice questions. Make your mistakes early such that when you are doing the next question, you are telling yourself, don't repeat that past mistake. Remember, when you are doing revenue analysis, you have to do the revenue mix. If you are doing a unit analysis, you use the unit mix. So split again, 59,603 in that ratio, and let's have what A and B will be.
A is 42,073.
A is 42,073. B,
17,530.
17,530. So that is the revenue for each product, which if we add it together, will give us this guy.